Hey everyone, and welcome to today's Explainer. We've got a really exciting one for you today. We're taking a massive 33-module enterprise curriculum on performance engineering and boiling it down into a single high-octane roadmap. If you've ever found yourself wondering how the internet's biggest platforms stay online and lightning fast under just an immense amount of pressure, well, you're absolutely in the right place. Let's get right into it. You know the exact feeling we're talking about here. You're trying to snag that massive Black Friday deal. You click Add to Cart, you kind of panic click it 5 more times, and the loading wheel just spins forever before the whole page crashes, right? But why does that actually happen? Well, getting to the bottom of that high-stakes business reality is exactly what the performance engineering framework is all about. Believe me, it is the crucial difference between a record-breaking sales day and a total, very public catastrophe. Okay, let's dive into this. Here's our blueprint for mastering zero downtime system reliability. We're going to start with why system performance matters, then hit the testing lifecycle, check out the essential tools and monitoring, talk about finding those tricky bottlenecks, and finally, lay out your career roadmap. All right, kicking things off with Section 1, Why System Performance Matters. What's really wild about these technical glitches is how fast they translate into massive real-world disasters. When an enterprise system buckles under pressure, the cost of failure is just brutal. We're talking about banking systems crashing and literally locking people out of their money. We're talking huge e-commerce sales dropping to zero mid-event, massive ticket booking failures during huge concert releases, payment timeouts right when you're trying to buy. When performance tanks, revenue and user trust vanish instantly. It's a complete nightmare scenario. So, how do engineers actually prevent these disasters before a single line of code goes public? Let's move to Section 2, the testing lifecycle. To really wrap our heads around this, we need to separate two concepts. Functional testing asks a basic question. Hey, does the login button work? If one user clicks it and gets in, awesome, test passed. But performance engineering looks at non-functional requirements. It asks a way harder question. Can 1,000 people hit that exact same button simultaneously without the server completely melting down? We aren't just testing if the code works, we're testing if it can survive the sheer chaos of the real world. To pull this off, engineers rely on the Software Testing Lifecycle, or STLC. Think of this as your ultimate battle plan. First, requirement analysis sets the goals. What exactly do we need to survive? Then, script development creates the simulated user actions, basically faking the traffic. Next, test execution fires that heavy simulation right at the servers. And finally, monitoring and analysis tells us exactly how the system held up under fire. Now, as we actually run these tests, there are a few baseline metrics we have to keep an eye on. First up, response time. This is just the total time it takes for a system to process a request and react to you. It's the absolute baseline for how snappy an app feels. And get this, if response time lags by even 2 seconds, studies show users will just abandon their carts and leave. Next is throughput. This is the amount of data or transactions the system processes in a given time frame. So if response time is all about speed, throughput is all about muscle. It's the true measure of how much actual volume the server can physically shove through the pipes at once. And here is the big one, concurrent users. This is the number of people interacting with the app at the exact same time. And make no mistake, this is the exact metric that shatters unprepared systems. Handling one user quickly? Easy. But picture a massive Taylor Swift ticket drop, hundreds of thousands of fans slamming the database at the exact same millisecond. That is what causes those crashes we talked about earlier. To prepare for that kind of onslaught, we use the testing arsenal. Load testing checks normal expected traffic. Stress testing pushes the system like a weightlifter, lifting until total failure. Spike testing mimics sudden, crazy bursts, like a TV ad airing during the Super Bowl. Endurance testing is a marathon, seeing if the system survives over a 24-hour period. And scalability testing makes sure the system can actually grow. These aren't just simple tasks. They're aggressive strategies designed to push systems to the absolute brink before they ever go live. But how do we actually simulate that traffic and watch the system break? Let's jump to Section 3, Essential Tools and Monitoring. To generate all this chaos, we bring in the heavy machinery, the load generation engines. We're talking about tools like JMeter, K6, Gatling, and LoadRunner. You can literally think of these tools as massive roaring engines. You script the user behavior, turn these engines on, and they simulate these massive tidal waves of traffic crashing against your app's architecture. But hey, firing the traffic is only half the battle. If JMeter is the engine simulating the traffic, these monitoring tools are your dashboard warning lights. Grafana and Prometheus collect metrics to give you these beautiful, high-level dashboards. Meanwhile, Dynatrace acts like an MRI, scanning deep inside the code to find the exact root cause of a slowdown. AppDynamics tracks complex business transactions. Together, they basically give engineers X-ray vision into the servers. Armed with all that data, we shift into detective mode. Section 4, Analysis and Finding Bottlenecks. When running a root cause analysis, engineers pretty much know exactly where the gremlins like to hide, and this brilliantly illustrates that breakdown. In most enterprise setups, roughly 40% of the time, your bottleneck is a sluggish database, usually because too many people are trying to grab the same data at once. 30% of the time, it's clunky app code, 20% is a network jam, and about 10% of the time, it's just an overloaded CPU. So when engineers go digging into the data, they're hunting for the usual suspects. They're looking for CPU bottlenecks. They're hunting down memory leaks, where the app just slowly gobbles up RAM until the server starves. They're tracking down slow database queries, or network deadlocks where two processes are endlessly waiting on each other. These are the specific culprits you have to totally squash before you ever give the green light for production. So, how does learning all this detective work translate into your actual career? Let's wrap things up with Section 5, your career roadmap. Everything we've covered today maps perfectly to a really exciting evolution of skills. You might start off as a performance tester, just executing basic scripts. But as you master these tools, you level up into a senior performance engineer, actually leading the analysis. Eventually, you step back to design the entire strategy as a performance architect, and ultimately you reach the apex as a site reliability engineer, or SRE, where you're ensuring the total architectural resilience of the entire company. But to hit that top-tier SRE role, you've got to look ahead. You have to move past manual testing and embrace shift-left testing, which basically means testing performance early in the coding phase, not at the very last minute. You need to bake performance checks right into automated CI/CD pipelines. It requires deep observability and, increasingly using AI to predict and automatically fix issues. Which leaves us with this million-dollar question. With AI stepping in and automating all the basics of performance testing, will you adapt, master these high-level enterprise skills to become an SRE, or are you going to get left behind? Thank you so much for hanging out with me on this explainer. I really hope this roadmap leaves you fired up and ready to conquer the full masterclass. Catch you next time.